Chapter 12, Section 2, we're going to look at rate laws in this section. So, a rate law is going to tell us how rate depends on concentration of reactants. Now, we would have talked about this in general in first year chem. We would have talked about the fact that if we increase the concentration, we would therefore then see an increase in the rate of a reaction. And the reason why that would happen is because you would have more particles per unit volume. And anytime you have more particles, you're going to get more collisions that occur. And any opportunity we have to increase the number of collisions will increase the rate of our reaction. Okay, so a rate law actually looks like this. It says that the rate is equal to my lowercase k here, so we'll talk about k here in a second. And we're going to use the equation that we used in section 1, where I have my nitrogen dioxide gas decomposing to form nitrogen monoxide and oxygen gas. And rate laws only use the reactant, so in this case, NO2. And the reactant is going to be raised to a power n. Okay. So we're going to talk about n here in a second. All right, so first of all, notice that only the reactant is what appears in my rate law, and the reason that occurs is that it's being studied initially. Okay, so it's being studied under conditions where the reverse reaction does not contribute to the overall rate. So in other words, we're trying to study it right as the reaction begins to occur. So that's the first thing to note. The second, let's talk about the variables in the equation. So this K is known as the rate constant. Now, it's not constant in the term that it's the same for every reaction. It's just the same for this particular reaction. So it's, in other words, it's determined by experimentation. And then let's talk about N. So N represents what we call the order of reaction. So it's important to note this is not like how we set up Q and K. We are not using the coefficients in the balanced equation. Okay. In other words, the way we actually determine N is by experimental data. Now, there are two types of rate laws. There is a differential rate law and there is an integrated rate law. So let's talk about the difference between the two. In the differential rate law, we're going to write a rate law expression. That's what we just looked at. And what this tells us is how the rate depends on concentration. And in the integrated rate law, we're going to talk about how concentration depends on time. Now, when we talk about the integrated rate law, we're going to talk about the order of all the reactions and how, if I know the order, how concentration changes over time. We're going to look at problems related to the integrated rate law in 2 lessons. In our next lesson, we're going to look at problems related to the differential rate law. In other words, how can we determine the value of the exponent n? How can we determine the rate constant?